Here's an update. This is where we are. I've got the engine block built, the main bearing, the head is built. I've got the main shaft with the crank disc on it. The eccentric. Ready to rock and roll. The eccentric follower link. The piston. Well, had the piston. All I gotta do is find it now. So next is the connecting rod between the crank disc pin and the piston, if I ever find it. I'm going to build it from this material. Same material I built the eccentric follower link from. I'm trying to build it out of this piece of scrap. Well, it's not scrap if I can build it out of this piece that I got the eccentric follower link from. So, building the connecting rod is next. Actually, next is finding the piston. The piston was hiding way under the mill. Got it. Here's the connecting rod. I'm not real proud of the way I came up with this, the way I machined it. Started off with a piece that looked, well, this is actually two pieces. I built the eccentric follower links in batches of 3. So I started off with a piece that looked like that and wound up with a piece that looks like this out of it. And I did that entirely with a belt sander. I just don't have a good way to cut this thin material. It's 52.5 thousandths thick, and a slitting saw, at least the ones that I have, don't have enough teeth on it to do it safely. I've got saws that these Thurstons have, I don't know how many teeth, I can't remember how many teeth they have. But that's as many teeth as I've got on the slitting saw. And it just, what happens is the material gets caught in the teeth, and that's bad news. So what I need to do, I guess, is buy some real fine tooth slitting saws for material like this. But I did it on the belt sander. Had to clean up the mess. That's okay. So the next step with the connecting rod is to fit it. The overall length is not critical. As you can see in this engine, I left it long, and the shape of this rod a lot better than this one. But I left the connecting rod long. I kind of liked it that way. But I don't know what I'll do there. If I'll leave it long or shorten it. If I shorten it, I'll reshape the end of it. But the critical part, the critical measurements, are the distance between the hole for the crank pin bearing assembly, which I'll talk about later. It's not much of a bearing, just a piece of brass tube pressed into a hole right there, and the wrist pin for the piston. That's the critical distance, and the way I do it is I just fit it in there to where it looks right. Not only looks right, but is right. Here are the parts to the piston connecting rod assembly. The piston, connecting rod, and the wrist pin. I'll stick the connecting rod up in there like that and press the wrist pin through it, and that'll be done. And this little piece of tubing is the outside diameter is 0.157. So I'll take a number, this is not it right here, I'll take a number 22 drill and drill through here to the end of the connecting rod somewhere after I determine the exact length I need, the exact distance I need between the wrist pin hole and the crank disc hole. I'll drill at that spot, press that excuse me, piece of tubing in it, and it'll act like a bearing on the crank pin, which is the same size as this wrist pin, same diameter. It'll act like a bearing like that as the connecting rod moves in its pathway on the crank disc, like this one does. See this little piece of tubing right here? It acts as a bearing on the crank pin. So I'll start putting her together. Here's the piston and the connecting rod with the wrist pin punched through or pressed through there. It's a good fit. I'm happy with that. It may be a little tight, but it'll loosen up. The next thing to do is determine the distance between the wrist pin hole and the hole for the crank pin. Determining the distance between the wrist pin, or between the top of the piston and the bottom of that intra valve cylinder steam port, is pretty scientific. There's a lot of engineering, advanced engineering that goes into this. What I do is stick the connecting rod piston assembly in there and then watch to see that I've got it at the bottom of the steam port, and kind of pull the connecting rod over there a little bit so that the wrist pin will get right under the connecting rod. And then I wiggle the wrist pin back and forth while I push on the connecting rod. Makes me a little mark right there, and I know that's the top of that 1/8 inch diameter pin, so I'll come down a 1/16 of an inch, and that'll be the center, the lateral, is it, would you call that the lateral center, the horizontal center of the for the hole. Then I'll find the center of the workpiece, the vertical center, put a mark there, and I'll have a nice little X, and I'll drill her out. The completed piston connecting rod crank pin bearing assembly. I put that little tube in there, and it slipped right in. It was too loose. So I, as you can tell, used a little red Loctite. There's going to be almost zero pressure on it. It'll be fine. However, next time I might go, instead of a 0.157 drill bit, I don't know, 0.154 is the next one. That might be too small to press that copper tube in. Maybe I can buy a 0.156. Maybe they make them. I don't know. Special order type of deal. Since I build several of these engines, it might be worthwhile. Anyway, there it is. Wish I had a better way to create these connecting rods. create them out of this stock. And this is the eccentric follower link I cut out. Then I use the remainder for the connecting rod. And whether I'm doing the eccentric follower link or the connecting rod, I don't have a good way to do it. Using the slitting saw works, as I said earlier, but I don't have a one with enough teeth in it. I guess that's the answer. Just break down and buy one. It's time to build the valve. I'm going to build it out of a piece of 1/4 inch diameter drill rod. The length I've got in there now is about it's over 2 feet long. I want to try to keep it. I'm going to keep it long until I've finished machining the valve, with the exception of cutting the valve off from separating it from the length of the drill rod. That way I have plenty to hang on to, both in the mill and in the lathe, without wasting any. I could just chop her off now, say at 4 inches or so, and have plenty to build that 1 1/8 inch long valve. But then I'd waste somewhere down the line. What would I do with a 2 7/8 inch piece of drill rod? Well, I'd figure out something. But this way, I don't waste any, or very, very little. So I need to find the, here's the drill rod. I need to find the center of the drill rod across here, and then I need to find the end of it and come in 1/8 of an inch to drill a 1/16 inch through hole for the wrist pin. So here we go to find the edge of the drill rod. Looks good. Now I'll come in 1/8 of an inch, and plus 1/4 of an inch for half the diameter of that wiggler, and that'll put me in the middle of that drill rod. I've located the place for the wrist pin hole. I've center drilled it, and now I'm going to do a 1/16 inch through hole. Gotta be careful with these little center drills and 1/16 inch bits in steel. They'll snap, especially the center drill. I use lots of lube on these little ones. I use lots all the time. Alright, so I've got the wrist pin in it. Now it's time to slit it. Slitting saw's next. I'm going to slit this valve to be a total of 0.250 inches. I might have said I was going to slit it a depth of 0.125 inches earlier, but it's 0.250. This first cut is just a test cut. Just see how my setup is. use a lot of juice on slitting saws. Got my vise mounted sideways so I can use my x-axis power feed. I'm just taking 0.10 of an inch cut this first time around. It's about ready to touch soon. There we go. Everything looks good, so I'm going to take 40 thousandths, and from then on I'll just take 50 thousandths inch cuts. I don't suppose you need to see all of those. It gets kind of boring quick. All right, here's the end of the drill rod, which is, you know, pretty long for this 1 1/8 inch valve. But like I say, I didn't want to waste any material. Here's the wrist pin hole. And then here's the slit right here. I'll show you what to do with it. Here's the eccentric follower link. Fits right up in there. It's got a nice hole in it, and a 1/16th of an inch dowel pin will go through there to pin those two together like that. Now I'm going to form a valve, the spool valve itself, on the lathe. I've got the valve mounted in there, chucked up in the lathe. And I've made relief cuts here and here to the correct depth. And I need to cut between them. Things are a little close right here, but it's going to clear. I've got my hard stop set on my lathe. And the finish between here and here is irrelevant. I just need to take this material out. So that'll help a bit. What I'm worried about though is this is a 1/4 inch stock, and I've got it sticking. I'm sticking way out here, 1 3/8, when the rule of thumb tells us to stick it out no more than 3 times the diameter, which would make it 3/4 of an inch. So I'm 5/8 of an inch too far. We'll see if this works. I think it will, because I'll take real light cuts to keep from breaking the workpiece, or probably more relevant, bending it. That looks good. I'll chop it off and leave an 1/8 of an inch head on it. There's the valve. Turned out nice. Here's the assembled valve and eccentric follower link. I pressed a 1/16 inch diameter dowel pin in there to act as a wrist pin. It was a quarter inch long, and I needed it to be, it was 3/8 of an inch long. I needed it to be a quarter, so I took it down to the belt sander and sanded her down. So anyway, this is what the valve assembly looks like. It goes into the, up into the valve body like that. And of course it fits on the eccentric follower link. Probably have a little fitting to do, but that's next. There's everything except the flywheel. Let's see if we can fit this baby together. I'll stumble around a bit doing it. The piston, or the cylinder, is oiled, so I don't mind sliding it in there right now. Well, I'm running off the mouth about that. I better put a drop in, or two in the valve body. Alright. Probably would have been better to do this off camera and you wouldn't see me fumbling. See how this fits in there so neat? Voila, there it is. I'll just tighten up the set screws and of course time it right. But we're not ready to run it yet anyway.